Okay. Once again, very good evening and thanks for joining. Firstly, I think everyone celebrated nice the Christmas. Okay. So last 2 days, we are completely in the celebration mode. Now let's go for again back to our technical stuff. As part of today, okay, we are going to discuss about the architecture. Okay. One of the key component being we are learning any product, being we are learning a product, a new product, okay, we must and should know how architecture is working. So I will go little slow, okay, mostly the architecture part, okay. No, everyone knows that there is a New Year celebration, okay, and it will start in 2 days, okay, 2 days, okay. I will go little slow. Once our New Year completed, then I will go for completely the core component of our architecture of the PostgreSQL. I will walk through what are the components are available and how what are the terminologies you need to remember. Let's stick with that one, okay? No. Wait. Come on, shit. I can't mute it. So first, let's go through the architecture of the PostgreSQL. Okay. So what we are going to discuss in next 2 to 3 session is completely architecture, and we'll try to compare with the, if possible, we will try to compare with the Oracle. Okay. Anyone can just address me. What is the difference you can notice when in terms of PostgreSQL, and I will also try to compare with the SQL. Okay, so I will try to compare with the SQL, PostgreSQL, and Oracle architecture. Let's see how easily you can understand how our PostgreSQL engine is working. Okay, so being we are going to learn a PostgreSQL, first we wanted to know how architecture is working, means how internally the Postgres engine is working. Engine is working. Next, how to install that engine, how to access that engine. These are the three major things we need to remember. These are the three major things. Not only PostgreSQL, if you go for any database management system, first we need to understand what product we are learning. Next is how that product is working. Front end is very easy because we are keep on connecting to the PostgreSQL front end. Our main focus is the back end basically. Our main focus is the back end, means back end how we are trying to connect. One second, okay. Sai, can you just reach to Annabelle? Okay, I just removed him because I am unable to mute him. Can you tell him to rejoin? Okay.
Okay.
Yeah. Yeah. So everyone, we must and should know how external it is working, how internal it is working. Our main focus is the internal, how internal it is working. Next, our focus will be how to install that product. As a DBA, we must and should know how to install the product. As a DBA, we must and should know how to connect to that product. Later on, we will discuss whatever the components, whatever the features, everything are available in that product. First, as a DBA, we must and should know about how that engine is working, okay, how to install that engine, how to access that engine, okay, what is the functionality we need to take in care when we are going to install, when we are trying to access it. Let's see. So understanding about architecture like a PostgreSQL architecture, whatever. Okay. Main, we know that being we are a database administrator, being we are a SQL, okay, not SQL, PostgreSQL, we must also know about the memory architecture like shared memory, shared buffers, WAL buffers, and also process, what are the process are available, like a PostgreSQL process type, okay, Postmaster, okay, that backend process, client process, and also we'll discuss on the storage structure as well. Means how our data is storing internally. It means external, internally how our data, externally we can see certain things, but internally what is happening, how the data is storing also, we must and should know. And coming to first slide, what we are going to discuss is, you already know, I don't want to display this one. Okay, initial stage, I just opened DB underscoring engines ranking. We already discussed that PostgreSQL was first released in 1989. Okay, and lot of enhancement has been done. And bean it is also introduced means completely written the code to fulfill the SQL. Okay, now they name it as a PostgreSQL. Now we discuss many things on that internal part. Okay, just overview of the history. Now PostgreSQL is also one of the leading database engine in terms of ranking. When you compare with the other database management system, it is also one of the leading the database engine. So that's the reason we are going to mainly focus on how that engine is working, means how PostgreSQL architecture is working. I just created 3 slides, okay, saying let's see all 3 slides, then you will get a better understanding first. Slowly I will go. I don't want to go deep dive in the starting phase itself. Okay, being we some people are learning first time, or some people are from Oracle to PostgreSQL, or you are from SQL to PostgreSQL. Let's understand the terminologies first. Okay, now there will be Postmaster. Okay, first this is the process. Nothing. Postmaster is nothing but a server. It's a server. Okay, PostgreSQL server. Okay, when you start the PostgreSQL instance, okay, for your understanding, uh, we uh, we know that the instance is so familiar, right? Once we start the server, PostgreSQL server, okay, by default we will get the Postmaster. Okay, is a main process, is a like a supervisor. For example, for our understanding, is a parent, is a parent process, is the main service, okay, which is running in the background, which is running in the background. Once your your process has been started, once the process is started, now what will happen? Users will try to connect to the engine. Users will try to connect to the engine. So user 1 is trying to connect, user 2 is connect, user 3 is trying to connect. Each user is trying to interact to the engine, PostgreSQL engine. Now, this technically we are calling as a post process. Process. It will create each request. It will create a process internally. Each request, it will create a process for us. Means, for example, see, main, this is our engine. Main, this is our engine. So once you started, okay, it will start creating. So for example, see, this is the Postmaster, this is the main process. Okay, now once you started, now it will start preparing the access. Now when you are trying to see, traditionally, see, once your instance is running, then user will start connecting to the PostgreSQL. Now they will start connecting to the server, and they will start creating the database, inserting, updating, deleting, whatever they want, they can do it. So now once they start accessing the engine, once they start accessing the engine, what is happening in the backend? Now there is a Postmaster is the main process. Under that there is a process. Okay, post process will be created. Each process is generated one ID in the background for every process. Each user, okay, it will generate one process ID. It will generate one process ID. Once it generate the process ID, then next step, next step is, so we are having, okay, here 3 things we need to remember. One is shared memory. Okay, under the shared memory, we shared memory. Okay, we are having the shared memory. We are having the background process. We are having the background process. We are having the shared memory. We are having the background process. We are having the physical files. Okay, physical files, and we are also having the archiving, archive, archive. So internally, we are having n number of process. Internally, PostgreSQL contains n number of processes. Once it start establishing the connection, the first major component where we need to focus is, okay, where we need to focus is memory, shared memory. Under the shared memory, okay, under the shared memory, we are having shared buffers, wall buffers, process array, and many things, many things. So shared buffers, wall buffers, process array. Let's focus these three first. What is this? Shared memory is nothing but, see, cache. Everyone knows about the cache, right? So memory, everyone knows RAM. RAM will plays a major role. In the PostgreSQL as well, RAM is placing a major role. Under the RAM, we are calling as a shared memory. Under the shared memory, we are having lot of memories. So what they done means they created the shared buffers memory, wall buffers memory, process array memory. So we are having n number of memories internally, means in terms of caches. So we are having multiple caches. We are having multiple caches. Out of that, all the caches, this is the most powerful. Shared buffers is the most powerful cache. Entire shared memory, shared buffers cache is the most powerful and most consumer, and one of the most consumer. Once you started the process, for example, user 1 is trying to insert the data. User 2 is updating the data. User 3 is deleting the data. User 4 is performing a select statement. Now, how it is happening in the background? First, let's focus on the reads. Okay, later on we will focus inserts, update, deletes. As you know, in the SQL also we discuss same thing. First, our focus will be select statement. Means if user is trying to read the data, how the engine is working in the background. Same way we are explaining here how this engine is working in the high level. So first, it will go to the shade buffers. It will verify any any blocks are available. Blocks are nothing but you can make like a page. It's a 8 KB only. Don't think that okay. In SQL also we are having 8 KB page. Each database is 8 KB. But don't compare with SQL, okay? Don't compare with SQL. But Oracle people you can try to compare mostly it kind of similar. But SQL we should not compare the PostgreSQL because this engine is running on the Linux platform, which is designed by like a kind of Oracle kind of stuff. So shared buffers contains the blocks. Shared buffers contain the multiple blocks. Like a block size is like 8 KB, like a page. It kind of page. Now, whenever, for example, whenever you are reading the data, when you are reading the data, now first it will go to the postmaster. From the postmaster post process. From the process, it will go to the shared memory. From the shared memory, it will go to the shared buffers to verify any data is available. Again, I'm telling, I'm just discussing high level. I will go little deeper first you understand this terminologies. Okay, because you need to check the syntax checks, you need to check the semantic checks, you need to prepare the plan. Correct, as a you are a SQL DBS, as you are a Oracle DBS, we know that it will check the syntax checks, semantic checks, it will prepare the plan, right? We'll discuss that stuff, okay? First, let's understand high level, then we'll go little deeper in the next session. Now, first, when you are reading the data, first it will go to the shared buffers. It will verify any data is available here. Currently, there is no data. Now, what it will do? It will go to the physical file, okay, and get the data. And it will get the data and will place it will one copy here and sends the data to the requester. So here also same concept. Here also same concept. When you are trying to read the data, okay, it is going to the shared buffers and verify any data is available. In case if data is available, it will try to send the data from there itself. In case if data is not available, it will try to get the data from the data files and it will place in the shared buffers and it will send data to the requester. But make a note down here. Yeah.
Subbu, yeah, I have a quick question.
Yes.
So, can you hear me?
Yes, yes, Gautam. Yes.
Yeah, okay. So you're saying that the process, the server will create a process, right?
Yes.
That is the same process that is going to shared buffers, or it will create a new process that will go to
process
data
is a
file.
request. Like in terms of request, for example, you wanted to read the data, you will get one process ID, right? Because you are performing certain thing. That what you are doing, we don't know, right? You are inserting, updating, deleting, or selecting. For example, I'm talking on the select. When you performing select, what is select? You are reading. You wanted to read the data, correct? Select is nothing but you are reading the data.
Right.
So how that algorithm background is doing means first it will go to the shared buffers, verify any data is available related to this. this. Like this, you can also call it as a, if you are a SQL DBA, call like a data cache. Easily understand. You know about data cache in SQL, right? Everyone, the people who are, most of the people are SQL. Okay, you know data cache in the RAM, right? No, in the storage of
Yes.
in the
Yes.
storage part, there is a data cache. Like a shared buffers is nothing like a data cache for us. Data cache for us. Okay, where it is trying to first go to the data cache, verify any data is available or not. In case if data is available, it will sense data from here. If not, it will get the data, place one copy, and sends the data. Is it clear, Gautam? I'm
Yes,
just
yes, sir.
I
Thank you.
what I want to convey today. Today means it's very difficult to digest these terminologies. Okay, so that's the reason I'm not going for little deeper architecture, high level only. The flow of architecture, high level architecture. Next session I will go little deeper. Okay, syntax text, semantic text, all the tests I will talk, and I will explain you what is happening, everything in the background. Okay, let's discuss about the high level. Yes.
So I think just to add on to the question, is it then a process, and in SQL, is it the same as a session?
For example, yes,
So
right,
a
you are right.
process,
So in the SQL Server, it will generate one SPID, right? When you when
yes.
you
So it's
when you when you go for SQL, it will generate the SPID. See, once I establish any connection, it will generate one SID for me. Like same for PostgreSQL also, it will generate the process ID. I will show you. Okay, where I can see that process ID. Where I can see
yeah.
that process ID. So once you start this okay connection. So for example, to show you understand, if I go to the, this is my engine, my PostgreSQL engine, but currently not started. See, there will be one process ID. There will be one process ID. See, are you able to see everyone PID? Yes, no?
Yes.
Yes, like this, you will get the process IDs. Okay, now based on your request, now it will go. So whatever it may be, insert or update or delete. First, we wanted to understand select, then I can go for insert, update, delete. Is it clear, everyone? First point clear, everyone. Postmaster is a parent, means a supervisor kind of. Okay, without Postmaster, you can't. Postmaster is nothing but server, sir. Without Postgres server is running, you can't authenticate to the PostgreSQL engine, right? Yes or no? Agree, everyone? Is this point is clear? Without this engine is running, see, without this engine is running, okay, I can go to the CMD.
It is nothing but protocol, Subbu, in the sequence.
Sorry.
It is nothing but
It's a SQL engine, right, sir?
No, it's a Postgres engine, okay? Without that engine is running, how can you authenticate to the database? How you can access, how you can read, how you can insert, how you can perform nothing, right? If this cluster is down, so specially we are calling as a cluster. This is like a cluster, okay? The installation is little different, sir. When you specially go for PostgreSQL, this is like a cluster. If this cluster is down, means entire server is down, okay? Or you not yet started the service. See, if you install SQL Server, you will get a when you go for services.msc. Okay, hey, where is it? Sorry. So if you once you install a product, you will get the services here, right? Yes or no? All the services. It can be any. For example, if you search for SQL, you will see the SQL. Okay. Now, if you stop this service, will you able to access? Will you able to access?
No.
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 Okay.
No.
Now, without starting this cluster, will you connect to the Postmaster? No. No.
No.
You need to first start this one. Once you start, then you can connect. Then you can connect. Now, when you are connecting, so for example, Adam is trying to connect, Ashwini is trying to connect, Avinash is trying to connect. Now 3 users who are trying to connect, 3 users, it will generate the 3 PIDs because each is a separate, right? Agree? Not agree? It will generate the PIDs.
Agree.
Okay. Now, once it connect to the Postmaster, once it got generated the PID, now it will start the processing your request, right? Means your authentication is done. See, without authentication, how you can do all this stuff? Now my authentication is done. Now I want to know how internal it is processing. Mainly, there is a cache, shared memory. This is the key component we wanted to know. Under this, so you are having shared buffers, WAL buffers, process array, many things. Let's focus first on the shared buffers. Nothing but data cache, where your data is available. Now, you know that always RAM is a faster than disk. This is the disk where your data is available. Okay. See, this is your RAM. This is your storage. Is nothing but disk, sir. Which is the faster? Disk is a faster, RAM is a faster. Everyone. RAM, because it is in the nanoseconds. Okay, this is milliseconds. Okay, disk will measure in the form of milliseconds. RAM will measure in the form of nanoseconds. Okay, always RAM is a faster. Now, like same, bean it is also one of the engine. It try to keep the data in the RAM. On the RAM, we are technically calling as a shared buffers. We are technically calling as a shared buffers. In the shared memory, in the whole RAM, there is a major key role that is nothing but shared buffer. Is a cache. Is it clear, Gautam? Still you are having any doubt?
Sorry. No. Sorry, I forgot to put it on mute.
Oh, okay. I thought you were unmute, right? That's what. Okay, now see. Now, being you are running first time, there is no data in the shared buffer. Now, what it will do? It will go to the data file, get the data, place it, and sends to the user. Assume this is running by Avinash. Okay, Avinash, next time it is triggering. Same query, next time is triggering. Now what it will do? It will go to the shared buffers, verify, okay, data is already available. And now it will try to get the data from the shared buffer only. We won't go to the data file. Like in traditional, in all the database management system, same hierarchy only. But again, there is, make a note, sir, there is one more call. This is shared buffer cache, and we are having one more cache called OS cache. Okay, we are having one more called OS cache. Sometimes your data will be in this cache also. Okay, see, don't go deeper. And it may confuse you. Okay, let's understand. So we are going to spend 3 to 4 sessions on architecture only, so that you will get to know all the internals. Then you will get so much clear of how engine is working in the background. So when you are performing anything, first it will go to the shared buffers. First it will go to the shared memory. Under the shared memory, it will go to the shared buffers, verify any data is available or not, and it will verify OS cache, any data is available or not. In case if these two caches, there is no data, then it will go to the data file, get the data, and place copy in the shared buffer. Is it clear? Is it clear, everyone? Now that data will send to the requester. Okay? Not okay. Everyone.
If data is not available in the shared buffer cache, it will go to the OS buffer cache, right?
It will also verify OS cache. That's it. Okay? Just make a note down, sir. We are not deep diving, okay? We'll see later on. Okay? Once we start installing the product, once we start using the products, we'll go and deep dive more in the architectures. Okay? No worries. Let's high level understand. First, it will verify the shared buffers. This is our primary cache. Okay, and it will also try to verify anything is available in the OS cache. If nothing is available, then directly it will go to the data files and get the data. Okay, data files in the sense, don't think that this is like a MDF. Okay, no, sir, it's a file. I told you, right? In PostgreSQL, everything will be sitting under the file. File. Okay, file. This is your table. In this table, there is a data. Okay, like this. If you create a table, it will create this kind of files. Okay, and that file only the data is available. Don't think it will create a MDF kind of LDF kind of stuff when you compare with SQL. Okay, but that imagination is completely wrong, sir. When you create any table, what is happening in the background? It will create one file for you. In this file only, your data is storing. By seeing the number, we can get to know, okay, this is so and so table, so and so data is available. We can see later on. Okay, once we install the product, we'll get to know which ID mapped to which table, so that we get to know, okay, this is the employee table, this is customer table, this is department table, this is sales table, this is orders table, this is some other product table. Got it, everyone? So now this file will move into the, okay, now this is how your data is storing in the form of files, data files. Okay, in the form of data files, that data will copy to the shared buffers. Now it will send to the user.
So
Got
each table, each file is tables, correct? That's what you're telling.
Yes, yes. Okay, that's what. Don't go deeper. Okay, I will start creating a table. I will show how what is the ID it is generating, how to get to know. Okay, this ID belongs to which table. Okay, we'll see all the information slowly one by one. Is it clear, everyone? First select statement. No. Yes. Everyone clear? Not clear?
Yes.
Understood.
Now, for example, again say, okay, user one is trying to perform insert or update or delete. Now we know about select statement. Just now we know about the select statement. What is happening? So first it will go to the Postmaster. It will make the authentication, get the PID. Once it got PID, then it will directly go and verify whether data is available. If not, it will try to go and read the data and place one copy in the shared buffers and send the request to the user. That's it about select statement. Now let's focus more on the insert, update, delete. Insert, update, delete. Assume when you are performing insert, update, delete. Okay, you want to perform insert, update, delete. Now, see, before we go and discuss, we need to know about, about shared buffers now. It's like a data cache. It's like a data cache. Shared buffers are nothing but like a data cache. There is one more buffer here. Very important. These two are very important, everyone. These two are very important. What is this WAL buffer? WAL is nothing but write ahead logging. We know many people know about WAL. WAL is nothing but write ahead logging. Okay, write ahead logging. Even SQL is also contains. Even if you go for Oracle, also it contains the same information. WAL stands for write ahead logging. Means if you are making any changes, it can be inserted, it can be inserted, it can be updated, it can be deleted. How internally the engine is working, means now it will start all the changes before it go to the data file. Before directly, see, first it will go to the data, first it will go to the shared buffers. It will verify the files are available or not, means blocks are available, pages are available or not. In case if not, it will get the data from here and it start modifying, right? Before directly move into the data file. Okay, there is a concept called WAL. All the changes, whatever you are going to do, all the changes, whatever the changes that can be insert, update, delete, whatever the changes you are going to do, that will be registered in a WAL buffer. That will be registered in a WAL buffer. That will be registered where it will register in the WAL buffer before it go to the data file. Before it go to the data file, it will register in the WAL buffer. Again, sir, don't get confused. Don't get confused. There is a WAL buffer. There is a WAL segment. There is a WAL buffer. There is a WAL segment. See, if you go here, and there is a concept called WAL, PC_WAL. Okay, see, very important, PC_WAL. So this is in the disk. Okay, this is in the disk. It means your segment is in the disks. This is in the buffer. Okay, means RAM. This is in RAM. WAL buffer is nothing but RAM. WAL buffer is nothing but RAM. WAL segment is nothing but disk. Your data is in the disk. Like it's kind of log only, sir. Log means all the change related information, whatever the changes you are going to perform, all the changes information will be registered in the WAL buffers, and it will move to the WAL segments, into the WAL, into the disk. It will move into the disk. Like same, right? In SQL also there is a concept called MDF. There is a concept called LDF. So your data will move into the data file, log will move into the log file. Correct? Like same in PostgreSQL also, engine is working same. Okay, now whatever the changes you are doing, before it go to the data files, it will go to the WAL, which is available in the disk. So there is a WAL buffer in the RAM, WAL segments which are in the disk, because always means see, whenever if something happen when you reboot the server where our PostgreSQL engine is working, all the caches will erase. So all the caches will erase. So we can't relay to keep the data in the RAM. We can't relay to keep our data in the RAM. Now what we are doing? So we are moving our data from WAL buffer to as a WAL segment into the disk, In case of any disaster occurs, we can recover the data with help of WAL segments. With help of WAL segments, we can recover the data. Is it clear, everyone? No? Yes? Are you there, online people?
Whenever we are performing update and insert, it will go to the first WAL segments, right? You are saying?
Parallel, sir. Parallel operation, right? See, this is the data cache. This is the log cache kind of. Simple for our understanding. This is the kind of log cache. This is the kind of data cache. Now, parallelly, your data will go to here and it will go until unless you commit. It won't move data to the data files. You can't move data to the data files. That is a traditional approach only. I'm not discussing anything, something strange, sir. As you already know, the hierarchies. Very simple. Until unless you commit, your data can't move to the data files. Your data can't move the data files. Now, what is happening? Okay, whatever the changes you are making, all the changes are registered in the WAL buffers, as well as it is moving to the WAL segments. Now you will get who is moving all this one. Correct? If you understand this concept, next question you will get it is who is moving. First, you understood this concept, everyone? No? Yes? This is a kind of log cache. This is a kind of log file. This is a kind of data cache. This is a kind of data file. Simple for your understanding, sir. Is it same in Oracle? I just asking the people who are working as a Oracle, okay? Is it same? No, it's any difference.
Yes, Subbu. Oracle has also the same kind of article.
Yeah.
It
Is
has data
SQL
buffers and it log buffers,
okay.
log files, it has everything, yeah.
Okay, great. Thank you. Is it SQL people understand, everyone? No, yes. Still you are having any doubts? So SQL also same, right? I should not repeat more on SQL. SQL also same.
Yeah, got it.
No questions? Now, next thing you will get one doubt. Who is moving all this one? See, sir, there are n number of background process. Okay, busy writer, stats collector, checkpointer, okay, archiver, okay, auto vacuum, log writer, okay, and wall writer. Like see, there is two things here. Also, two process. One is busy writer. One is a checkpointer. One is a busy writer. One is a checkpointer. These are the two process which is going to taken care to move data from the shared buffers to the data files and make this as a clean page. Now, once this page has been modified, this is the page. Once you start modifying this page, you will call it as a dirty page. Dirty page, correct? Dirty page. When the busy writer triggers, when checkpointer triggers, when busy writer triggers, when checkpointer triggers, what is happening? Whatever the dirty pages which are available in the shared buffer, not yet moved to the data files, all the data it will move to the data files and may mark them as a clean page, as a clean page. Okay, as a clean page. And in the WAL buffer also, okay, it will mark like activity is completed. For example, okay, transaction is completed. Like this, it will mark in WAL buffer. It will also mark in the shared buffers whenever checkpoint triggers, busy writer triggers. Now, forget about frequency, all this stuff, sir. I'm not talking the frequency, all this stuff now. Next, slowly, I will make you feel too comfortable, all the frequencies, all the stuff. Is it clear? First thing, whenever busy writer triggers, whenever checkpoint is triggered, if your transaction is completed, now it will try to move the data from the shared buffer to the data file and update in the shared buffer as a clean page, because the page which is modified, not yet moved to the disk, that page will call it as a dirty page, right? Same algorithm. Now, in the WAL buffer also, it will update the information. It will update in WAL buffer. It will update in the state buffer whenever busy writer checkpointer triggers. Clear? Not clear? No, this two process clear, everyone? No? Yes?
Sir.
Come on, sir. I can repeat. Okay, n number of times. Don't feel, because we are learning new technology, right? Definitely. And I am also new to this, right? Definitely. Okay. I will spend more time for you. You can stop me if you're not understanding.
So can you just repeat a little bit on the wall buffer and the PG right and the checkpoint? I think I missed that point.
Which one? A busy writer and checkpointer. So what
So
is
how they
this two
function,
process? Sorry.
how they
Yes.
function on the wall buffers?
Sorry, Adam. Can you repeat?
Or I'm asking how they function on the wall buffers. I get the part where they on the shared buffers where they push the DT pages to the data files, but how do they then push the DT
No,
or
it
in this
is
update?
not pushing. It need to update in the WAL buffer, right? See, if you are
Oh,
not updating, how you can truncate the data in the WAL buffer? Correct. If the transaction is moved to the data file, it need to update in the WAL buffer as well, right? WAL is a kind of log. If you're not updating information in the WAL, can you truncate it? Can you remove it? Because otherwise, your WAL buffer will grow like anything, right? This will grow. Your disk will get full, right? If you're not updating. So whenever busy writer checkpointer trigger, it is not only it is updating the shared buffer like a dirty page to clean page, it is also updating the information in the WAL buffer about that transaction has been done. Means that data has been moved to the data file. Is it clear, Adam? No. No.
yes.
Yes.
Yeah.
Okay. Thank you. Now you will get one doubt. Okay. Now everyone is clear about this shared buffer. Shared buffer is like a data cache, and who is moving the data from data cache to the data file? Either busy writer, either checkpoint. Forget about frequency, all this stuff, sir. We'll see in the upcoming sessions. Now you will get one doubt. Okay, there is a concept called log cache as well. Nothing but we are calling it a WAL buffer. Now who is moving this data to the disk? Okay, because we can't relay the data in the cache, we need to move data to the disk. Who is moving? There is a concept called WAL writer. There is a concept called WAL writer. This WAL writer will take responsibility. Whatever the changes are available in the WAL buffer, it will move into the disk in the form of WAL segments. In the form of WAL segments, it will move the data from buffer to disk. Buffer to disk, it will move. Clear? Not clear? about WAL buffer, WAL segment, who is moving, WAL writer is moving, about shade buffer, who is moving shade buffer to disk, busy writer, check pointer. Regarding these three background process and these two, everyone clear about these segments? Who is moving your data from WAL buffer cache to WAL disk? This is the disk. This is the storage. Who is moving? WAL writer is moving.
WAL writer.
WAL writer is moving. Yep. No. Yes. Clear. Because these are the main process, our first focus. Later on, we will focus about the auto vacuum, archiving, all the stuff. No, auto vacuum, I will take a separate session. MVCC, I will take a separate session to understand more about what is plain vacuum, what is full vacuum, what will happen when you go for plain vacuum, what is vacuum firstly. Being we are a SQL engineers, we are completely unaware of this concept, and this is one of the most important. Oracle people can understand easily this one, but SQL, it's difficult to digest, but I will make so comfortable in terms of vacuum, auto vacuum. As of now, no need to worry. We'll see in the next session. Okay, now I wanted to share one more thing, sir, here. It's simple, not that much complicated. So there is a error log files. Okay, PostgreSQL is also contains the error log files, right? Now, related to all the error log files, who is writing means there is a thread called log writer. There is a process, background process called log writer. That log writer is going to take care to write the error log information in the error log files. Okay, log writer will take responsibility to write the errors information in the error log files. In the error log file, this is going to taken care. This is going to taken care. Okay, we discussed today 4 concepts. One is shade buffer, WAL buffer, busy writer, check pointer, WAL writer, log writer. Even if you go for next slide also, see, if I go for next slide, here also say there are multiple background processor running like a logger, check pointer, background writer, WAL writer, auto vacuum launcher, stat collector, okay, logic replication launcher. Okay, so we are having multiple background process which are running. Out of this, we discussed today log writer, okay, log writer, check pointer, background process, WAL writer. Only these 4 we discussed. First 4 we discussed in the background process, and we discuss basically, okay, WAL buffer and shade buffer. WAL buffer, shade buffer. And we discuss about the data file, and we discuss about the WAL file, not WAL archiving. We are not discussing anything. We haven't discussed that stuff. We discuss only data file, WAL buffer, shade buffer, log writer, a check pointer, background writer, WAL writer. Any questions on this part? And we discuss about the post process, and Postmaster is nothing but server process. Postmaster is nothing but server process, and post process is nothing but background process. Every request, it will generate a process ID. It will generate a process ID, and based on your request, how it will work means when you are performing insert, update, delete, it will work with the WAL writer, WAL buffer along with the shade buffer. When you are reading the data, it will work with the shade buffer only. That's it, sir. Today, I just wanted to discuss. Any questions on this part? Can I restrict the shade memory? Can I restrict the WAL buffer? Yes, sir. Everything we can do. Here, 2 things very important. One is PostgreSQL.config, PZ HPF.config. These are 2 very, very important config file. Okay. One is authentication, host base. Okay, this is our authentication, and this is the main thing where we want to learn more. Okay, whole 2 days, 2 to 3 days we'll spend only on these files. 2 to 3 days we'll spend only on this 2 files. Now think about how important this is. So forget about the other stuff. If you want to do strong, so PostgreSQL is very easy. If you want to do strong on PostgreSQL, we mustn't should know about how to configure all this stuff. What is work mem? What is maintenance work mem? What is temp buffers? What is WAL buffers? What is shade buffers? How to restrict? How to grant? What are the best practices we need to follow? That is what we wanted to know, sir. That you can do everything in the PostgreSQL.config file. So today we just discuss what is shade buffer is like a data cache. What is WAL buffer? It is like a log cache. Like a cache, we are having like a WAL file and as well a data file. And who is going to write? Busy writer and checkpointer who is taking care to write the data from the shade buffer to data file, and the WAL writer will taken care to write the data from the WAL buffer to WAL file. And now when it is writing, it will technically call it as a segments. Why it is writing that information is in case any disaster occur, we can recover the data. That is also we'll see, sir, when we go for backup, restores, recovering, all the stuff. Like say logs, how it is writing, like a log writer is taking care to write the logs. Are we going to have all the explanation in details in class material as well? It will take some time, Wilson. Okay. Being I started journey as a PostgreSQL, right? I will take some time to prepare everything. Maximum whatever I am preparing, I will share it to you. Okay. Maximum stuff you will get it. But try to stick with the live sessions always. Okay. Easy. It's easy. It's not that much complex, but you need to remember the terminologies, like components you need to remember. That's the reason I told you that I will go a little slow only, not I don't get hurry, okay? Because next slide's also very simple, but where is my mouse? Okay, here also same. See, now we wanted to understand these components. First, our main agenda is we wanted to understand these components, the terminologies. Okay, the terminologies are very important. So in technically, in a traditional, we'll call it as objects, like a table is object, view is object. But in PostgreSQL, we'll call it as a relational. Okay. Technically, we'll call it as a rows. In a table, we'll call it as a rows, but you will call it a tuple here. Okay. So the name is something different. Okay. So you need to understand the components first, because it's a new, right? That's the reason I will cover slowly everything one by one, slowly. Okay. That's it. Over to you. Any questions?
Sir, in this Postgre, how the connections will be made, sir, through TCP or any name pipes? In SQL, we have, right?
TCP IP only, not named pipes, not shared memory kind of stuff. Okay, it's like it is. I will talk, Malti. Okay, because this is very important, and this is the game changer. This is very important. This is the game changer. I will talk more on these files, more. Okay, more on this to come, because when I'm researching, when I'm talking to the other DBAs, okay, they told me more. If you know these two, if you know the background process, we off of the PostgreSQL, you are already good. Later on, you know how to create the database, you know how to create the table, you know how to insert the data, you know how to update the data. Okay, you know how to take the backups, you know how to restore it. Now, what else we can do in the PostgreSQL? Nothing. Our main focus is this one. If you understand this one, what is the PZ bouncer? Okay, what is pooling feature? This is very important, because multiple web application is, whenever multiple web application is connected to the Postmaster, is a server process, we may experience some time modes. To avoid this time modes, we are going to create the PZ bouncer, okay, which will improve the connectivity faster, and we are going to create the pooling feature, all the stuff. I will talk more, okay?
Yeah. Okay, please just explain again. Sorry to take you back. Between the WAL writer and the log writer, I think I missed. I'm writing notes here, and I think I missed a few things.
This is a buffer, correct? Cache. Okay. This is also cache. Nothing but RAM. This data is available in RAM. This is also available in RAM. So we can't relay with the RAM, right, Adam? Okay, because if suddenly operating system got rebooted or suddenly something is trashed, we may lose the data which is available in the RAM. Correct? Yes or no? Yes, no, everyone.
Yes.
To
Yes.
make what we are doing, we are moving the data to the data files. We are moving the changes to the WAL in the form of segments. Okay, in the form of segments. So who is writing this data from WAL buffer, which is in the cache to the disk? This is in disk. This is in disk. Okay, who is moving? WAL writer is going to take care to move the data from the WAL buffer to the disk in the form of segments. Now you are clear? No?
Yes. That one
Yeah.
I'm fine.
Okay. What still?
So I was saying the log writer between
Oh,
WAL
log
writer.
writer. Oh, log writer. Okay, sorry. Oh, I thought wall writer. Sorry. Okay, log writer is, see, you will have when you are processing something, maybe the time modes or query time modes or processing time modes or some, you got some errors. Okay, who is going to take care to write the information into the error log? Error log. Error log, right? Someone need to take it to write the information in the error log, right? Who is going to take care? The log writer is going to take care all the errors into the error log files, so that in case you can go and you can start reading the error log, you will get to know why, what happened. So you got some information, right? Like a SQL error log, SQL error log, right? Like same here, there is error log where error log files where it will write the information. You can go and you can start reading the data. Got it?
Oh, okay. Thank you. Thank you.
Yeah,
I get
yeah,
it.
yeah. Good, good. Anyone still?
Subbu, you told there is postmaster.pid. There are generated for each connection like that. So each connection there will be separate that much files. You mean?
No, within their PIDs it will generate. I will show you, sir. When I just started connecting, okay, I will connect using command prompt. I will try to connect using PC admin. I will connect using DB ever. Okay, different tool. Let's see what you will see. Okay.
Yeah.
Yeah. Like same. If you go to the task manager, very simple. If you go to the task manager, okay. So if you go to the details, you will see here. Okay, here you will see the process. These are all the PIDs, process ID, Postgres IDs. It will generate.
So depend upon the connection, that much IDs will be there. Like for example, 100 people means 100 files will be there.
Yes.
Or?
Yeah. Yes. No, 100 files not. 100 connections are establishing, and each connection it will generate one PID for reference.
Oh,
Now we wanted to.
separate ID will be there. Okay.
Yes. Yes. And we can get that information, means how many connections we need to allow, all the stuff we can handle in the
Config file.
config file. Very important is a config file. If you open the config file, so if you go to the here, if you go to the config file, open with notepad. Okay. See here we can set the shade buffers. Okay. Temp buffers. So work mem. Okay. Maintenance work mem. There are many things that we wanted to learn. Okay. Slowly we'll make all this. So if you scroll up. Okay. You will see the maximum connection. What is the port number it is? What is the reserved connections? Okay, super user reserved connection. See, connections are very important. I will talk more on this part. Don't uh, uh, hurry. Okay, we'll go little slowly. I will talk more on these connections with different level of permissions, command line restrictions. We'll try to restrict and we'll try to authenticate. We'll try to restrict and we'll try to authenticate. Okay. Let's see what kind of errors we'll see, how to analyze that errors, how to troubleshoot in case of when you go to the real world. Yeah. Okay, sir. Not okay. Good. Not good. Everyone?
Okay.
Okay. Yeah. That's it. Thank you.
Thank you, Subbu.
Yeah.
Bye.
Thank you.
Yeah.
Thank you, Subbu.
Yeah. Bye. Have a great weekend, sir.
Thank you, Subbu.
Yeah. Thank you. Thank you.
Subbu, next class will be on Monday.
Monday.
Okay.
Monday. Okay. Let's complete our New Year celebrations. Okay. Then I will take. Okay. Your session will. Okay. Let's stop the recording. Sorry.